I think like the common misunderstanding is like, okay, we had the liquid cooling and then the problem is solved.
Welcome to Parker Hannafin's manufacturing location in France. I'm Alice, and today I'm joined by Mathieu, and we're talking all about densification in data centers and how it can increase performance and also minimize risk. So, what is densification and what does it mean for data centers?
So densification is basically having more computing power in the same floor space. But a data center rack is a standard. So usually 19-inch or 21-inch. And that's, let's say, a defined space. So then the challenge is how to increase that computing power into that limited space.
So, why is liquid cooling becoming the default response?
So the liquid cooling is becoming the default response because the AI rack has so much computing power that the amount of heat generated is massive. So then you cannot just cool those kind of racks with air cooling anymore. Just as an example, the current AI rack solution has a power of, let's say, between 100 to 150 kilowatts per rack. So that's a massive computing power. Just by comparison, it's the equivalent of the power of 5 to 6 houses in a system. So that's really massive. So then the liquid cooling, and especially the direct-to-chip liquid cooling, becomes a must-have.
So how can operators increase compute capacity per rack without adding any floor space?
So the operator can, of course, they will start by increasing the computing capacity itself. So for that, they have basically two options. They can scale up at the chips level. So that means develop new chips with higher power. That's what the chip manufacturers, let's say, do almost all the time. And they launch new chip. And they can also what we can scale out. So use the same chip, but multiply the number of chips you have in the server trays. For both of those options, you have any way to scale up the cooling loop and the liquid cooling system. So that's the second step. So for that, you have to increase the flow, because the more you have, the more flow you have, the more you'll be able to reject the heat and to manage this heat. So you have to increase the connection sizes, the tube sizes, manifold sizes, and also your cooling distribution units capacity. And then the first step is, okay, you have a very good and, let's say, efficient system, but you have to control this system and having the proper monitoring, because your system starts to be very powerful and at the limit. So you have to make sure that you can monitor it perfectly.
What's the most common misconception you see about densification when it comes to data centers?
Yeah, so densification is not just more kilowatt per racks. It's more about controlling everything with a higher efficiency, like the flow, the heat, the hydraulics, everything, also the service. So I think like the common misunderstanding is like, okay, we had the liquid cooling and then the problem is solved. In the reality, that could not work like this, and you will face a lot of trouble. So you have to consider the liquid cooling as a system integration problem, and you have to think about it early stage, or to integrate this entire liquid cooling design to your rack.
As systems densify, what seems to catch engineering teams off guard?
I would say that the first point would be the design of the cooling loop. Surprises often, because the design starts to be very complex. It's not just having, okay, it's having more flow, but you have really to design precisely everything. So using full flow connections, also make sure that you have such amount of flow into the system that you have also to balance everything. Make sure that on all the servers you will have a constant flow, and let's say the same flow, that all your server will have the same cooling performance, right? The second one for me would be the disconnection aspects. The disconnection integrates some, or let's say adding some pressure drops into the system. So that means if you had too much disconnection, you will have lots of pressure drop in your system. And of course, if you have too less, you will potentially have some serviceability issue or operational issue. So that's a trade-off you have to manage. You have to select the proper area you will have to disconnect for your service and operations. The last one is about the detection. So you start to have a very complex system with lots of things to be controlled. So the monitoring and control becomes mission critical.
And to close on a more practical note, if teams want to connect multiple liquid cooling loops quickly at scale, what should they look to standardize?
I think they should start about standardizing the connection itself. So the connection, you have some full flow connections inside the server. You have also quick disconnects to have the serviceability. So they have to make sure that they have small sets of connectors, okay, and not a variety of different types of connectors all around. The second one for me would be the disconnection aspects. Disconnection and especially quick disconnections with non-spill can introduce some pressure drops in the system. So you have to find the right area to have those disconnections for the good serviceability. So you have that's a trade-off you have to manage, like having not that much disconnection because you will have lots of pressure drop, and also having those disconnection at the critical area where you need to disconnect. The other thing is about the material. In the rack and in the liquid cooling system, you have plenty of different types of material. You have metal, you have elastomer and plastics. So you have to try to limit those different materials and try to select just few materials that are really compatible with the fluid and with the cooling system. And the last for me is about the test procedure, so the validation test that has to be standardized to have also a consistent performance.
Perfect, that's super clear. Thank you so much. From higher densities to lower temperatures, join me for the next episode of Insight to Impact, where we'll be looking at creating reliable cooling solutions. See you then.